Today we are featuring a learning session centered around Home Networking 101. We will break down this presentation into two different sections. The first section will feature basic networking concepts and bandwidth suggestions. But in the second section, we will take the concepts we've learned from the first part and expand upon them, do a deep dive into how wireless networks work and what to look out for when configuring yours. A recording of this video will be made available later via OIT's website. We will pause after the first half to answer some submitted questions before proceeding on to the more advanced part of the presentation. So before I introduce myself, I would like to take a second and mention that some of the topics highlighted in today's talk are also featured on OIT's COVID-19 Resources page. It's a great resource, right? I'm always learning something new about some new service or how to leverage my association with CU to access discount government programs or just basic how-to articles. My name is Drew Smorrell, and I will be the presenter for today's session. A little background on me: I've been working in higher ed for the last 20 years. Most of my professional career has been focused around network infrastructure, and I'm currently employed at CU as a network engineer. After moving to Boulder from Pittsburgh last year, I've had the privilege to work for the Network Engineering and Operations Department within the IT Infrastructure and Engineering Division, which is ultimately under the guidance of the Office of Information Technology. The team I work on affectionately goes by the acronym NEO. Pronounced Neo, yeah, just like the movie The Matrix. So if you hear me use that acronym in the future, you'll know I'm not referring to the movie. I by no means am the only person working in NEO, and I'm fortunate to have a tremendous team of people working alongside me. The folks at NEO are working hard 24/7, 365 days a year to make certain the physical network infrastructure across campus stays up and running, along with a long list of other responsibilities. So enough with the introductions. Let's get started, shall we? Today's agenda, we are going to cover what is an ISP. Then we will define some terminology and discuss the different types of connectivity ISPs currently offer, what a typical setup looks like in your home, and a specific terminology associated with that. Hopefully, the discussion will guide us into topics such as bandwidth speeds and what OIT considers adequate bandwidth for remote teaching and working. How to test your speeds the right way. We get to answer the age-old question, to VPN or not to VPN. Then we will discuss some tips and tricks as it applies to your home networking setup. And at the end of the session, if we still have time, we will try and answer some questions from the audience. It is OIT's goal to make sure after watching this session, you will come away better informed than when you first started. Before we get into the nuts and bolts, let's begin with defining some technical terms. What is an ISP? Quite simply, an Internet Service Provider, or ISP, is an organization that provides services for accessing, using, or participating in the internet. ISPs can be organized in various forms, such as commercial, community-owned, nonprofit, or otherwise privately owned. Today, we'll be focusing solely on commercial providers, since they are the most common and offer the easiest setup for most people. Right? You know all of these companies pretty well, right? We have Verizon, Comcast with their Xfinity service, AT&T, CenturyLink, along with some others. Basically, these ISPs can be broken down into two different camps. ISPs that provide connectivity through a cellular wireless connection, like AT&T, Verizon, and T-Mobile, and which are sometimes referred to as carriers. Or they provide service through some sort of cabling system. An example would be Comcast's coaxial infrastructure that is already run to many of our homes. Or if you're lucky enough, you might have a newer fiber optic line run to your house, like some of our neighbors over in Longmont. Who get that service luckily enough through their municipality. Also, we can't forget about digital subscriber lines, DSL for short, that provide internet service through a telephone line, like CenturyLink offers. And if you're thinking he didn't mention satellite, I omitted it on purpose, right? The assumption is that if you're savvy enough to set up a satellite dish and beam signals into space, then you probably don't need us telling you what you do and don't require for connectivity. But all joking aside for now, we will omit it as an option. But if we get enough questions surrounding this, we may put together some information and post it on the web later. All of these services are determined by what we in IT call the last mile. The last mile quite literally means the final leg of telecommunications network that delivers telecom services to end users. More specifically, the last mile describes the portion of the telecommunications network chain that physically reaches the end user's premises. Furthermore, broadband connectivity can be broken down into different cable types. It can also happen over cellular, called mobile broadband. So let's first take a look at these last mile technologies as it pertains to cable type. Broadband speeds are limited on the cable type that carries the signal to your home and the service tier you have signed up for. Before we get into service tiers, there are three common types of cable broadband. A DSL modem is a device used to connect a computer or router to a telephone line, which provides the connectivity for your connection to the internet, which is often called DSL broadband. Usually you have a modem that dials out to an ISP, and then a router is used to supply internet connectivity within the home to devices either through an Ethernet cable or a wireless signal, depending on the modem router type you have. This option is the slowest as compared to the other two, since it uses older telephone lines. These types of connections can get oversaturated very, very quickly. So if you have the option to select one of the other two choices, we recommend them over DSL. Cable broadband is somewhat different in that when you attach your device to a router that is usually but not always supplied by your cable company, the connection that is established is an extension of that ISP's network. Cable providers will combine customers into shared cable plans, usually based on your location to that ISP's neighborhood uplink. So if you live in an area that is congested, here's looking at you, residents of the Hill, or in an apartment building like me, you are typically sharing the pipe with the neighbors around you. This can sometimes cause slowness, especially in apartment buildings. For the most part, that slowness isn't really noticeable with higher bandwidth service tiers, but it is something to keep in mind. Cable broadband can provide a cheap and reliably fast internet solution to most homes and is recommended by OIT. Fiber broadband has the potential to be the fastest of the three. These connections use strands of glass that are the width of a human hair to emit light impulses over extreme distances. Fiber optics move at the speed of light and are only held back by the equipment designed to interpret those signals. So these types of connections can be future-proof. Fiber connections are also not pulled together like coax, which means no other subscribers share your link back to the ISP. This is considered the Cadillac of connections, right? If this is offered in your area and you have the means to afford this type of service, we highly recommend it. The last connectivity type is cellular or mobile broadband. Cellular connectivity, which could be provided by either a hotspot or a cellular phone with tethering enabled, can be a good solution for homes that do not have another last mile option. These types of devices are only as good as the plan that is purchased and the service signal the carrier can provide to your location. Most unlimited plans from the big three, you know them as AT&T, Verizon, and now the combination of T-Mobile and Sprint, they all have the ability to tether. So what do I mean by tether? And if you look at the slide, you can actually see what I mean by that. There's a phone there and it's connected to a cell tower. And then there is basically a wireless connection from the computer to the phone. So it is allowing your computer the ability to connect to the internet service on your phone. It's like creating a portable wireless network that you can take with you. Just remember that these devices and plans are limited to the signal strength provided to your area. Since typically these types of solutions were designed for people who travel and only need access to the internet sporadically, extra charges can apply to tethering. So the unlimited plan you signed up for may have stipulations in the contract that limit the amount of data that you can use for tethering. I have an AT&T plan with unlimited data, but my tethering is capped at 25 megabits per second for a given month. Also, some ISPs offer better service in certain areas based on the technology and spectrum they are using. In the testing our CU engineers have conducted in the past, it is shown that in and around CU's campus, cellular service can vary greatly. Cellular signal strength in certain areas and from certain carriers could offer excellent to good or even poor performance. So it's extremely important to make sure you pick a carrier according to the coverage maps that they provide on their respective websites. Also, don't be afraid to contact your carrier if the service coverage does not live up to what was promised. The other terms you hear frequently associated with cellular connectivity is 4G, LTE, and/or 5G. These terms refer to the G, or generation of technology that was developed to offer increased speeds and newer services that each new generation was designed for. 5G is the next generation of extremely fast service to be developed, and it's just starting to see adoption across popular cell phones, hotspots, and carriers. Just last week, I picked up my brand new iPhone 12 Pro, and it has the ability for 5G, even though my carrier, AT&T, doesn't actually offer 5G. Verizon does, and you will get charged an extra fee for that 5G service. It's not a good option to spend money on currently because 5G is not everywhere. So it's gonna fall back on 4G whenever 5G doesn't have a good signal. So just think about that whenever purchasing a new phone. When 5G is widely adopted and available, it is promised to deliver speeds similar to cable, with the caveat, depending on the service tier you purchase and your signal quality, right? We spent a lot of time talking about the finer points of each generation of cellular technology, but for the sake of time, let's move on to some key takeaways before we dive into another topic, bandwidth. So what are some key takeaways from this section, right? There are a ton of ISP choices, right? We have cellular, and then we have terrestrial, which is more cable-oriented broadband. You have to understand all of the different types to actually understand what's available in your area, right? So you may have a DSL line, but didn't realize that Verizon offers a fiber connection and that you may have to have the line pulled in. And in the end, the monthly fee for having the fiber pulled into your home or your apartment may actually offset the cost for the DSL connection, and then you're getting much faster service. And then one of the things we want to kind of push is to avoid cellular and DSL options. And I know the DSL thing's an issue. I'll talk about it at the first break, but it's just too slow of a connection currently to offer all of the services that someone needs. And we'll point to that later in the presentation. So let's move on to bandwidth. So now that you have a better understanding of the physical types of service that can be offered, we can begin to discuss the nuts and bolts of the terminology behind what they actually offer, right? You might have heard me mention the term megabits per second, M little b, little p, little s, right? To understand megabits per second, you need to have a general idea of what the term bandwidth means. Bandwidth is another common term you hear when discussing your internet, and is intimately related to megabits per second. Bandwidth at a basic level is the total download rate of your internet service, i.e. the fastest that you'll be able to download information or data to your computer or internet connected device. It can often be described with the metaphor of a water pipe, right? If you need to fill a 5-gallon bucket with water and your pipe can only put out 5 gallons of water each minute, it'll take 1 minute to fill up that bucket. But if you upgrade to a larger pipe that can fill 1 gallon per second, and now your 5-gallon bucket will be full in 5 seconds, 12 times faster. So your bandwidth can be thought of a lot like a water pipe, and your data is the water flowing through it. The larger your pipe, the more data that can travel through in less time. In internet terms, we'll talk about data in terms of gallons per minute though, right? We measure them in bits. That's where megabits per second come in. So Mbps refers to your download and upload speeds. However, there's another very similar acronym out there that means something quite different, but looks very, very similar. Megabytes per second with a capital B. A megabyte is equal to 8 bits, like in megabits per second. The term megabytes refers to the size of a file you're downloading, or the amount of data that has been transferred to your computer over the internet. Or in other words, the number of megabits per second is how fast you're downloading and uploading megabytes. Hopefully that makes sense. Got a slide here to kind of break all this down for you. So that's a quick breakdown of what megabits per second means, but how much do you actually need and how do you determine that, right? I think that's the most important thing. So now in most cases, the faster your internet speed, right, the higher number next to the megabits per second, the better, right? Yeah, in most cases, yes, it's gonna be true. But how much is enough is going to depend on your usage. And all of the estimates listed on the slide come directly from the FCC's website. So I'm just gonna kind of call out video calls at the bottom. The FCC has then decided to put out documentation to kind of let people know what different systems or activities people use in their home and what minimum download speed is necessary for them to actually have those services work. So this is a great little call out by the FCC. If we look here and you see video calls there at the bottom, that's 6 megabits per second, right? That's down. And we're not talking about up yet because there's going to be download and upload speeds, and I'll discuss that later. But right now, just for a basic video call, it's 6 megabits per second. So let's say you had a DSL connection and you only had 20 megabits per second on your DSL line, and you had 3 people in your home and they were all on the same Zoom session. You probably are pretty close to maxing out your digital subscriber line at that point, right? So this is just a nice little breakup of different activities and how much megabits per second they actually take. So I had mentioned the FCC's website earlier. The FCC website has a ton of useful information, all in one easy to get place. They list all of this information, and they also offered an easy to read and downloadable PDF. So I recommend that you go to it. You don't have to go to that specific URL, but they do have a consumer section and a consumer guide section that I'd like to point to as being particularly good. So speed comparisons, right? So how does the download speeds we've discussed so far compare to how long it takes to download a file? Here's a good approximation of how long it would take to download a different file size per a few select bandwidth speeds, right? From this table, we can clearly see that as the file size goes up, the need for increased bandwidth is very apparent and can drastically increase the time in which it takes to download your data. So just quick here, I'm going to look at the bottom row, a 45-minute HD show, that's 600 megabytes. If you had a 1 megabit connection, let's say at a really bad cellular connection, it's going to take you an hour to download that 600 meg file. If you had a 5 megabit, you probably have a not so good DSL line or cellular, it's 15 minutes. 10 megabits is probably on the higher end of DSL or mid-range DSL, that's 8.5 minutes. 20 megabits per second is probably the highest that you're going to get on a DSL, that's 4 minutes. And then we threw in 100 megabits per second and 1000 megabits per second. I did this because the majority of people probably plug in their computer or Ethernet if they don't have wireless. And this is a good representation of if you had a 100 megabit connection or you had a 1 gig connection, you can actually see the differences. So if you're at work and you're on wireless and you're wondering why it's so slow, the best thing to probably do is to get an Ethernet cable and plug in. You're going to get speeds that'll be way better than you would over wireless. Hopefully this is all making sense. We'll move on here. So let's take this one step further and apply what we've learned to an application that you might be using while working from home. So what application is most widely used and most bandwidth intensive during COVID-19? Zoom. Zoom is the most common denominator across all departments and has the highest bandwidth requirement as compared to most standard applications used by CU employees. And during COVID-19, it has also become the de facto standard application for many people who are teaching, working, or learning from home. From this slide, you can see that Zoom's highest requirement at 1080p, and for those of you who don't know what 1080p is, it's the resolution quality of the video you are viewing or sending. You might have heard me mention before, like a 4K TV or a 5K monitor, which both offer extremely high resolution quality pictures. 1080p can sometimes be referred to as 2K, but no one really calls it that, right? The K just refers to the number of horizontal pixels a device has, 2000 for a 2K or 4000 for a 4K. So according to Zoom, streaming at 1080p is a solid 2.5 megabits per second to receive video and 3 megabits per second to stream from your HD camera. I also know what can increase this significantly is if you have 2 monitors running. So if you're someone that has a nice setup at home and you have 2 monitors up and your one monitor has 50 people on it and the other monitor just has the one person, you're going to be doubling the amount of bandwidth that you're going to need to actually be able to do that. Also pay attention to the upload speed, which I will describe in a bit later. You can see that using Zoom via an application on your phone or tablet can significantly decrease your bandwidth needs. So if you only remember one thing from this session about Zoom, please keep this in mind. The better it looks, the more bandwidth it will need. So bandwidth planning, how do you plan all this up? So it's pretty simple. It's just a couple things that you need to kind of put together. So how do we build a plan to determine what my household's bandwidth needs are? In doing so, we should consider what other types of devices you have or you would like to have on your home network. My home network has a series of internet connected lights that I can control via my HomePod. Now, what you probably don't realize is you think when the lights are off, there's really no data flow. That's not really true. Those devices are constantly sending data back to their cloud servers so that you can interface with them at a moment's notice. So it might be something you're not even thinking about. Maybe your home has a Wi-Fi connected lock or something like that. That all uses bandwidth. So you should add that all into your planning, right? So what types of services do these devices use? Are they streaming services? Do they just need to hit and ping a website to see if it's up? Are they passing any kind of data? The lights that I have in my home will update the firmware every once in a while. So they'll push code to every single one of my lights in the middle of the night, right? It usually wakes me up because all the lights go off and on. So how much bandwidth is needed for these applications and services? And most importantly, how many people do you have living with you in your home? And is everyone using those services and apps at the same time? Just like the water bucket scenario, right? We want to make sure that the pipe is big enough to fill all of the buckets equally at about the same time. So more users equals more megabits per second, right? It's easy stuff. Remember the water pipe analogy, like I said earlier. Let's take that a step farther. Your internet represents one 5-gallon bucket. Add on another family member as another 5-gallon bucket. If only one of you is using the water or bandwidth at a time, then there's no problem. But let's say both of you go on simultaneously. Now your pipe has a splitter, so the water can go to each of you, to each one of your baskets. But it's still the same total number of gallons flowing through the pipe. That means each of you will have slower rates than the one of you alone. And you can easily expand this comparison to 3, 4, 5, or 6 users, right? And it's easy to see how everybody's internet speed would be reduced. And that doesn't even take into account what each individual is doing online. Streaming in 4K, more data is definitely needed. Browsing, not so much. So the more internet users in your home, the more megabits per second you will typically need. So in this chart, you can kind of, it's an old chart, so the light moderate is really no longer in use. If you're just doing basic browsing and maybe pulling in some mail, you're not doing anything that's video related, you're probably fine with those numbers, right? At the quantity of people. But for most people in most jobs, you need to have a higher bandwidth limit. So I would definitely look at the very last section here, the very high usage, and kind of use that as your guide to kind of figure out based on how many people. So my wife and I, we both live together. We have a 50 megabit per second connection, and that seems to be pretty good for both of us right now. There's a caveat to that I'll explain later, but for most people, that should be good for 1 to 2 people. So let's put this all together, right? So that this makes some sense, because I know I went off on all kinds of different tangents. In the end, bandwidth, megabits per second, and megabytes per second are all related to your speed. Hopefully we've explained that well enough and you have a pretty clear understanding by now, but let's just recap it one more time. Megabits per second, how fast a file is downloaded to your device and how fast one can be uploaded to the internet. Megabytes per second, file size, the larger it is, the larger it will take to download or upload from the internet. A general rule, the more megabits per second you have, the faster your music, videos, web pages, etc. will load. The opposite is true too. So let me close by saying this. There's a balance to be found in all of this. ISPs want to sell you as fast a speed as possible, which may be very well beyond what you need. So evaluate what you and the other members of your household use the internet for, and use that to guide your decisions. Do not pay more for what is necessary. All right, key takeaways for this section. When figuring out your bandwidth needs, one must consider megabits per second is not the same as megabytes, right? But they both have to be understood to determine what the bandwidth is. Understanding your internet usage based on the applications and protocols used is very important. The more megabits per second you have in your plan, it will equal faster download speeds. The more people you have in your household will increase bandwidth requirements. So ISP recommendations. Bandwidth slowness not only comes into play when you have a slower or older connection type, have a service tier that limits your speed, or you have too many devices running at the same time. Taking these things into consideration, it is not OIT's recommendation to use a mobile or cellular broadband service through Verizon, T-Mobile, or AT&T if you have more than one person using the service at a time. When 5G becomes more widely available, like I mentioned earlier, this might change. But for now, when you think of a hotspot or a tethered device, just think one person at a time. I'm going to separate DSL from the other broadband offerings because DSL is limited by the legacy technology it uses. Using telephone lines to send digital signals is very old technology. Think sending a fax, right? And as these devices and users begin to grow on your home network, the bandwidth requirements grow as well. So having a DSL line shared among 1 to 2 people with 2 devices each should be at the limit of what that service can offer. This is assuming they are all online and using multiple devices and internet services at the same time. Cable and fiber broadband are pretty unlimited when it comes to the speeds they can offer. At that point, it will be the service plan they try and price you in at. Most of the carriers offer service from 10 to hundreds of megabits per second, but on average, you usually see anywhere from 50 to 150. With those types of speeds, multiple people in multiple devices all can work, streaming and browsing the internet with no problems. So this is the important point about upload and download. So like we pointed out earlier with Zoom, another thing to consider is the difference between upload and download speeds. Most ISPs offer very good download speeds and usually wholeheartedly market those speeds to customers as tiered packages. The upload is much different. Usually those speeds are way slower, and depending on the number of users and what services they are using, it may cause you slowness, no matter what broadband type you have. This usually is the case in homes with lots of people all video calling at the same time. As you pull down video from your meeting, you are also uploading video at the same time. Those uploads are usually less bandwidth intensive than the download, but can make it seem like your connection is unstable or slow if you push your upload connection to the max. This is just something to be aware of. I'm going to point to it in a second here. If you're curious, right, a good way to determine what types of speeds you're getting from your ISP is to use a free service to test your internet connectivity. 2 that Nia would like to recommend are speedtest.net and CU's own internal speed test site, speedtest.colorado.edu. I bet you didn't know we provided that service. Not a lot of people do, and I was pretty surprised when I found out. It is important to test with the same website each time because of inconsistencies in the function of all speed test sites. Without getting into all kinds of specifics, these sites use servers located all over the world, and some of the links to those servers can be pretty far away, skewing the results. CU's internal speed test site takes away all those extra routes and gives you a pretty good, clean result. Though I have seen on certain cellular networks, the web page will not function properly. Speedtest.net is another option if CU's site doesn't work for you. Just be mindful that this website automatically picks its destination to test to. It does this based on your current device's location, and that the destination location can change with each test. So it's always good to keep that in mind to test at the same destination for the most accurate results. Bear in mind that the connection to your router can also affect the speed, especially if your connection is slow or at the edge of in-house wireless coverage. So it's best to plug in directly into your router via an Ethernet cable to get the most accurate results. Quick disclaimer for anybody using an Apple laptop, all newer Apple laptops don't have a Ethernet port, so you may have to purchase an adapter. So what are the key takeaways from all this information that I kind of threw at you? The more people you have in your household, the higher the bandwidth needs. Best and most cost-effective option for most homes will always be cable and fiber. Fiber will be future-proof. Plans that range from 50 to 100 megabits per second range should be enough for most homes. Understanding upload versus download speeds and how this can affect your perceived speed, and using a test site to help determine your current speeds. All right. Before we get to the first break here, we in OIT get this question asked of us a lot, right? Do I need a VPN to do my work? Before we answer that, and now that you have a pretty good understanding of how data flows up and down and the required bandwidth to allow those flows, I need to discuss what a virtual private network is and what it does to your data. Simply put, VPNs extend a private network across a public network and enables users to send and receive encrypted data across those networks. The traffic acts as if their computing device were directly connected to that private network. So basically extending out corporate internet to your device or branch office while wrapping it in a nice encrypted hug. So why is that important as it pertains to bandwidth? When enabling a VPN, all traffic that originates from your device is wrapped up in encryption and sent securely over the internet. From that point on, the traffic you create actually goes through the internet to CU, and from CU out to its final destination, and then back to CU, and then crosses the internet once again before it ends up on your computer. Doing this can cause slowness because the encryption adds another layer of complexity. For each destination in the chain, your data needs to unencrypt and re-encrypt. This is why your connection can seem slower when you have a VPN running. So what's the answer, right? I didn't tell you if you should or not. I was like, it depends. As someone who has dealt with network security in my professional career, I would say yes, wholeheartedly. You should always use a VPN, especially if you're on a public wireless network like at Starbucks. But with most of CU's day-to-day services being hosted securely in the cloud, you may not need to connect, especially if you're working from your home office. OIT has compiled a list of services that you would need VPN access for, and they are access to CU Boulder's file servers, CIFS and NFS file sharing, access to CU's system administrative tools, access to Cisco's VoIP phone portal, and access to specific library databases. OIT also lists them on our webpage. If you don't need to access any of these resources, then you probably don't need to connect to CU's VPN, and that could speed up your connection. So key takeaways from this section before we move on to the first break. VPNs are a very secure way of accessing important and confidential files and services. In most cases, a VPN may not be needed unless special access is required. And VPNs can cause overhead and slow down your speed on slower ISP services like DSL and Cellular. So be aware of that. So before we begin with the second part of the presentation, we got some questions before the session, which we are going to address now. And if time permits, we may field some questions submitted through the chat in the audience. So one of the most popular questions is, what do I do if my DSL is my only option? You could try and contact the ISP and ask them if they will bond a new DSL line if possible. That is just adding a new internet service line onto your existing line and combining them to offer double the speed. We used to do that with 56K modems back in the day. You used to be able to bond them together to actually get double the speed. Keep in mind that extra fees will be added to your bill for that new service. They also offer something called a line conditioner, and that can kind of help clean up the signal on older telephone lines. So if you have an older home and the telephone lines are ancient, and you could get all kinds of interference from power lines or anything touching the phone lines behind the walls, that conditioner device will help clean up the signal so you get better speeds. They're not magic. I've seen them work somewhat well, but if in a pinch and you have no other option and DSL is your only option, might be something to ask for via your ISP. But with all this extra work, it might just be cheaper to go another route, right? Some companies offer fiber connections that can now be pulled into a home, even if you don't have like a coax cable through a cable company. Don't forget to browse our COVID resources page and see if you can apply for a discounted service through Comcast or CenturyLink. Lots of services and programs are out there. Don't be afraid to ask your ISP what temporary service plans they offer, or if they offer discounts to educators or government employees. Also, ask about contract terms. Some companies make you sign up for 1- and 2-year contracts. you might be able to talk them into a smaller term contract, right? Now that we're in COVID. The moral of all of this is, right, at the end of the day, it doesn't hurt to ask, right? You just need to ask. So let me switch gears over to the screen here and show you what a speed test looks like. So this is the Colorado speed test that we use here at CU. Just gonna go ahead and start it. See my connection on the download side, increase, increase, increase. So I did mention before that my tiered package is 50 megabits per second, but now that COVID has hit, a lot of the ISPs have automatically increased you up a tier or to their highest tier to kind of make up for the fact that a lot of people will be working at home and their service plans aren't up to snuff. So even if you were to buy, like, let's say the lowest plan, a 20 megabit per second plan, it might justify, or they might be able to just say, hey, we're going to give you the 150 anyways for the 20. So that might be something else to look out for. The other thing here is to look at the upload. See the difference? The download is way, way faster, but the upload speed is a lot slower. So if I had, let's say, 10 people living here and all of them were trying to do a Zoom session, they were all taking a class at the same time and uploading their data, there's a pretty good chance that we wouldn't be able to do that with that many people in the house with a 19 megabit per second connection. Something to keep in mind. The other thing here is this is the speed test site. Remember I had mentioned that they will pick just random locations. That's actually changeable in this section. You can change the server, pick another one. So what we recommend is always picking the same server over and over and over again to get the best results, or at least the most accurate results. Okay, one last thing to cover in this section. This is another question, is ISPs are now putting cap rates on tiered packages, right? I know Comcast has started this recently. So along with the ability to up your tier for COVID, they also put a limit to how much data you can download in a month. So I'm not super happy about this, right? And things might change with a new administration and possibly a new appointment to the FCC. But how this works is that even though you may have 150 megabit per second connection, after hitting a total of 1.5 terabytes of data downloaded for the month for your home, you may see extra charges or a slowdown in speed as they might throttle your connection for the remainder of the month. The argument is that Comcast makes is 95% of customers don't ever come close to hitting the 1.5 terabyte cap limit. My average home network connection is around 600 gigabytes a month, and that's with 2 people working full-time at home. So that's just a way for you to kind of gauge what you're seeing versus what I have. Mobile broadband carriers used to do this back in the day to some degree, and I think some still do. They do that with tethering and some other things. So this is just something I want everybody to kind of be aware of. Okay, so let's move on to the second half of our presentation, and I know I'm a little behind. Okay, so this presentation is broken up into 2 parts. The first part was probably more basic information, but this is going to get into more advanced terms and understanding. So if I lose you, hopefully the demo at the end of the discussion will kind of help focus all of this information that I'm going to throw at you really, really quickly. So, okay, this is the more you know section. The segment will focus mainly on your home wireless network setup, and I may pull in examples from CU's wireless network, UCB wireless, as examples, since we're all kind of aware of how UCB wireless works on campus. We will be getting into some really technical terminology, so I will do my best to try and explain it in the simplest terms. I would like to note that since wireless is an everyday technology in our homes and offices, the fastest connection will always be through an Ethernet cable. Wireless should be viewed as a bonus and never fully relied upon if true speed is what we're after. It is important to note that I will be moving through a lot of terminology, but at the end, I will apply all of this knowledge in a demo that should explain visually what I'm talking about. So don't worry if you get lost. Hopefully, I will try to make sense of all of this at the end. Okay, so how many of you have ever used a walkie-talkie? If you have, then you already know that only one person can talk at a given time, on one channel at a given time, only within the range of the other person. Wireless networks work exactly in the same way. Okay, so what do you mean? Buckle up. The wireless router that many of you have at home is just like a super sophisticated walkie-talkie. There are channels you can tune into, and those channels can be grouped into different frequencies and radio bands. When you talk on a channel, you broadcast that conversation to anyone that is listening on that channel. So if you and a friend were talking and me in the hat pulled out my walkie-talkie and tuned into the same channel and the same frequency, I would be able to hear your conversation as long as I'm in your broadcast range and you haven't encrypted the conversation. It's also important to point out that if we were all talking at the same time on the same channel, what would happen? Nothing. We would all cancel each other out and have to rebroadcast again, one at a time. It's exactly how wireless networks communicate through the air. So wireless networks work on channels via specific radio band to send and receive data conversations. The only difference is that wireless networks move our conversations at lightning fast speeds. And just like with a walkie-talkie, the right rules, anyone can listen in on a conversation someone is having over wireless since the spectrum is open, just like the walkie-talkie example. Passwords and encryption make it possible for those conversations to take place in private. So don't worry too much about the security of your data because wireless networks employ encryption, just like a VPN connection does. When you password protect your wireless network, you wrap up your conversations in encryption so would-be hackers can't see your data. So please remember to change your default wireless network password with a more sophisticated password of no less than 8 characters, and that's numbers, letters, capitalization, and alphanumeric. But I thought, Drew, you said that encryption slows down your connection. I did, but it mostly affects software encryption and it doesn't affect hardware encryption. Your computer hardware handles the encryption at wire speed, unlike the software that runs your VPN, which is handled by your operating system. The slide shows a snippet of what an actual packet looks like. As you can see, the packet payload is encrypted, so we are not able to see its contents. The dark strip is the actual hash. If you had the password, you could apply that password and decrypt the hash. And then the information that's in the light blue, those bunch of letters, SSM, Z, 5P, that's actually real data. That could be an email message. That could be a text message. It could be a whole bunch of different other things. But since encryption has been turned on, me, the person who actually pulled this data from the air, can't actually see it. So it's important to always have a password. So what are the key takeaways from this section? Wireless networks communicate on frequencies that are publicly open, right? That's why you need a password. Interference can happen when 2 wireless networks talk on the same channel, just like a walkie-talkie. Please make sure to change the default password on your wireless router, please. That's one thing you take away besides the Zoom stuff is make sure to change that password. So let's get into the differences of generations of wireless connectivity. Yes, wireless is built on generations of advancement like cellular, but we refer to those generations slightly different. Some of you may have heard of the IEEE. The IEEE is a coalition of engineers, companies, and research institutions that work to create standards and protocols across the industry. You may have heard of some of these protocols, right? 802.11b, 802.11g, 802.11a, 802.11ac, and so on. These protocols were designed to provide Wi-Fi communications across several distinct radio frequencies. They do this over the air via specific radio bands. This might be familiar, and maybe you've heard the terms 2.4 gigahertz and 5 gigahertz, right? Those are the most common consumer bands available on the market today, and each have unique properties. Under each of those radio bands, there are a number of channels available to use, just like a walkie-talkie has. Before I begin discussing channels, we should put some sort of order to the succession of these protocols and frequencies based on their advancement. The most common legacy wireless standards are 802.11b and G, and they use the 2.4 gigahertz range exclusively. 802.11n and A operate mostly in the 5 gigahertz range, but they can also use the 2.4 gigahertz band. The 802.11ac standard operates only in the 5 gigahertz band and has some special qualities of its own. I know that's all super confusing, and trust me, trying to explain all this is even harder. But depending on the hardware generation, you may have incompatibilities with certain bands. The engineers who designed all of this made it so our devices will always try and steer towards the fastest network, so don't fret. Most modern computers and devices are backwards compatible. It is the legacy devices that may not work on the newer bands, and that's why most wireless routers are backwards compatible. 2.4 gigahertz band was deployed on some of the first Wi-Fi enabled devices and routers. The protocols used are not that important specifically, but with each new protocol, they adopted new features. 2.4 gigahertz is considered legacy and is being phased out for 5 gigahertz networks instead. So what has kept 2.4 gigahertz around today? 2.4 enabled networks have more power to penetrate walls and can travel longer distances, but the speed is much slower than 5 gigahertz. So 2.4 is a cost-effective way to supply coverage to outdoor deployments, which typically don't need high speeds, but lots of coverage. The downside is the number of channels offered, which is 11, but of which only 3 are usable because of overlap. In a large deployment of access points, APs for short, this is just another fancy name for the equipment that sends wireless signals to your computer, just like the wireless router you may have at your house, but a little bit more serialized. So in large deployments of APs, you need to make sure that each AP can detect one another on a different channel. So just like the walkie-talkie example we used earlier, if 2 APs are talking on the same channel and they are in the range of each other, only one can transmit at a time. The interface can cause retransmissions and collisions, which will ultimately slow your connection down. Proper channel planning allows your device to move smoothly between APs in an enterprise deployment like at CU. This isn't a huge concern at your house or in a small office, but in large configurations, this is a major concern since APs can only service so many clients apiece. Also, the speeds for these radio bands are ultimately slower than 5 gigahertz. And if I'm losing you, I promise that it will make more sense when you get to see it live. The 5 gigahertz band is newer and offers better speeds and more channels, but at a cost. And this diagram that you're seeing on the screen will kind of illustrate what I was just talking about. The power levels transmitted are much weaker, and it takes more APs to service the same area as a 2.4 gigahertz deployment. So in this scenario, you may have a 2.4 gigahertz signal, and you can go all the way out to your porch and still get connected. But to get a 5 gigahertz signal, you may have to put a mesh device or another access point out by your porch to get fast connectivity. There are a lot of solutions coming to the market that address this concern, right? You may have heard of something called mesh networking. I just mentioned it. And that's just a fancy way of adding more APs to your home network to offer greater coverage. Since, like I said, 5 gigahertz has a lower transmit power, you may need more APs to cover the same area. The 5 gigahertz band also has more channels, allowing lots of APs to be bunched together to provide faster speeds while servicing lots of clients. Since we have plenty of channels in the 5 gigahertz range, we can start to combine these channels that are next to each other to increase bandwidth and speed. And this is going to sound like crazy, but if you kind of look at the picture here, you can see that in the green, we have multiple channels, 36, 40, 44, 48. You have these channel widths, 20 megahertz, 40 megahertz, 80 megahertz. And you can actually bond channels together. So at 40 megahertz, I can bond 36 and 40 and get double the speed. You can't do that on 2.4 because there's only 3 usable channels. But when you get into the 5 gigahertz with the newer technology, you're able to do all of this crazy stuff, right? So when these are, you can put these together, we call it combining channels to speed up the service called channel bonding. So some of the other terms you hear associated with 5 gigahertz wireless is the 20, the 40, the 80, or 160 megahertz, like I mentioned. These channel widths allow you to bond together a number of channels to provide faster service. This is one of the main differences between 2.4 and 5, like I mentioned. From the slide, you can see how this is laid out per channel. For people with lots of wireless networks around them, switching to 20 megahertz will give you possibly more open channels to talk on. If you're all by yourself, somewhere nice in the mountains, good on you. You may want to set your channel width to 160 megahertz to get the faster speed from your router. So let me address one point that we might not have made clear throughout all of this. Your wireless connection speed to your wireless router is different than the bandwidth speed your ISP provides. Without adequate bandwidth coming in, no matter how fast your internal network is, you will always be at the mercy of your ISP. Same thing applies in the opposite. But remember, just because you may have a speedy connection to the wireless router in your home of, let's say, 255 megabits per second, but your ISP connection is only 50 megabits per second, what will happen? You will always be as fast as your slowest link. So key takeaways. Wireless networks work in the 2.4 and 5 gigahertz range. It's mostly what you're going to be kind of worrying about. 2.4 gigahertz is legacy and slower than 5 gigahertz, but penetrates through walls better, and the signal can travel farther. Has only 3 usable channels. 5 gigahertz is newer and faster than 2.4, but has a harder time extending and penetrating walls. This may have, it also has many more channels, which can be beneficial in apartments or in crowded neighborhoods. 5 gigahertz gives you the ability to combine channels to increase the speed of your internal network. And as always, you are only as fast as your slowest link. So demo time. So I'm going to demo some software that allows you to see the RF like your computer does. There are plenty of free utilities out there, so you can try one just like the one that I'm about to show. Some are built into your wireless router. I think Comcast has one that's built in. Some are built right into your computer. I believe Windows has a very nice a way to do that. There are also diagnostic tools that all Apple computers come with. That's a nice bonus. And plus there are plenty of free Wi-Fi scanners that exist in both app stores and are available in freeware versions. Another popular free tool is NetStumbler, which is available for Windows and as well as Macs. So NetStumbler is a great tool. I've used it in the past. I just kind of moved on to a different tool today. So let's take you in to how all this is going to work. Okay, so can you see my screen here? It looks like it's just a whole bunch of letters. Can everybody see that? Okay.
Letters?
So
we're like 64, 62, 63.
Yeah. Okay. So what this is actually doing is I'm running a command on my Mac, and what it's doing is it's pulling down my connectivity to my router real time. So as you can see, I'm sitting pretty far away from my router, but I have a pretty decent connection, right? So this has a lot to do with something we like to call signal quality. So one of the things you would like to know is the signal quality of your device to the AP in your home. So how do we measure this? And that's what you're seeing here, this RSSI, or Received Signal Strength Indicator. It's a measurement of how well your device can hear a signal from an access point or router. It's a value that is useful in determining if you have enough signal to get a good wireless connection. Note that because the RSSI value is pulled from the client, right? You're seeing what my client can see. It's received signal, not what's been transmitted. Not super important, but I just wanted to make the distinction. So these numbers that you're seeing listed here, this negative 60, negative 64, these are what we call decibel milliwatts. It's the most reliable method of representing signal strength. This decibel milliwatt is expressed as a negative number from 0 to negative 100. Therefore, a signal of negative 40 is more powerful than a signal of negative 80. A higher negative value indicates a weak signal. Hence, a negative 45 decibel will provide a better signal quality than negative 65. So, for example, a negative 30 dB signal is twice as powerful as a negative 34 dB signal. And a negative 84 dB signal is 4 times as powerful as a negative 90 dBm signal. The signal strength doubles every 3 decibels. So, you know, you may not realize that going from neg 67 to neg 64, that doesn't seem like a huge drop, but in decibel terms, it's actually a huge increase in connectivity. So I think Jamie's going to put in the chat just some basic information to kind of show you the breakdown of the different dB levels and what we consider good. So one of the things to look out for here is that if your connection is negative 67 dB or closer to 0, you are in the good zone for connectivity. You should be able to perform most tasks, if not all services, in a relatively fast way. So if your connectivity to your AP in your house is anything below 67, you shouldn't have any problem with any transfers of data. You should have a pretty fast, reliable connection. When you get above 67, it starts to kind of slow down. So we always use 67 as kind of a stopping point. So with that said, what I also want to do is for all of my PC and Mac people who want to figure out the best way to get this information is on, Jamie's going to put the links to both of these in the chat. There's a command that you can run on Windows from the command line. Just make sure that when you open up your command prompt that you do it as an administrator on your machine. And then inside there, you're going to get, if you type in this command, you're going to get all kinds of crazy information. And inside that information, it's going to tell you your transmit rates, your channel, a whole bunch of different things. And then the thing that Microsoft does a little different is the signal is listed as 100%. You know, it should be dB, but that's okay. That's fine. You know, I would think anything over 80% and above would be a good signal. And on the Mac, it's a little bit easier if you have a Mac and you have the little Wi-Fi guys at the top on your menu bar. If you hold in the option button and then click on that, it'll create a drop down, and that drop down, I don't know if you'll be able to see it on my machine, that drop down will have a whole bunch of extra information in there. And that extra information will actually show you what your RSSI value is. The same RSSI value that I was showing just a little bit ago. That right there. Okay. So how do we set up our 2.4 and 5 gigahertz networks, right, to channel plan? This is probably the most important part that I'm going to show you, and that could actually speed up your connectivity. Since there are so many different types of options when it comes to the type of router you may have, right, I'm not going to be able to show you how to configure every single type of router. So you're going to be kind of on your own for that. And you may have to do a Google search on how to change your channel or something like that on your device, on your router. Since most home setups allow for both networks, right? They both allow for 2.4 and 5 gigahertz, right? You can have both of them on and then get the benefit of having both networks. You have one, if you're close to it, you get fast connectivity. And if you're very far away from your access point, you still get connectivity, but it'll just be at a slower rate because of the 2.4's ability to penetrate. Instead, I'm going to show you what your computer sees. This is going to be actually what your computer sees when it connects to a wireless network. And this goes a lot to what I was talking about with the walkie-talkies. So here we are looking at the wireless spectrum in my apartment. And in my apartment, I have lots and lots of people connected, right? I have all these access points. And all of these access points are all using 3 channels mostly, 11, 6, and 1. When you pick a channel that's other than one of these, what happens is you can see like this Netscape Navigator guy is now going across 2 channels. So now anybody that's set up as 6 is going to have to compete with all of the people that are in 6 and also have to compete with people, this Netscape Navigator, which has now added connectivity. So if you see 1, 6, and 11 are being used up a lot in your area, try and pick one that has the lowest signal quality and go with that. So at my home, my network is called Airport. And you can see that I have a very good connectivity. It sees it almost at neg 43. That's excellent signal. And it's above all of the other signals it can see in the area, right? Even though there's cross-channel talk on channel 6, I still have a very good connection, right? So this becomes important, right? So when you run your analytics or you run a diagnostic tool that comes with your OS, it's going to kind of point you to a channel that you should kind of set your wireless router to. I know Apple does that, and I believe Microsoft does that. Sometimes it's not 100% accurate, but through the data that you can see, you can kind of come up with this this kind of plan and figure out exactly what's the best channel. So I picked channel 6 because at the time it had the least amount of people. And that's another thing. As people change and get added to your apartment building or leave, or into your neighborhood and leave, the wireless spectrum around you is actually going to change and become different. So it's also good to be looking at this, you know, every once in a while to make sure that you're using the right channels with the least amount of clients on them, or at least number of people that'll be talking on them. So let me switch this over to 5 gigahertz, and you're going to see huge difference. Now with 5 gigahertz, we have a lot of different channels. And remember, I told you, you could also bond these channels and create one big channel. And a lot of people do that. Defaultly, a lot of routers will automatically bond as many channels as they can, and then they'll take up, you know, all of these channels and be talking on all of them at the same time. In an apartment building, that sucks. But if you're at a, you know, like I said, if you're in the mountains and you're all by yourself, I would definitely do that, so then you would get the fastest connectivity from your device to your router. Now, in this scenario, there was nobody in my apartment building that was using channel 165. So I set my router to channel 165, and I changed the channel width to 20, meaning I only want to use the 165 channel. And as you can see, I have a really good, strong connection. I don't have anybody kind of playing with anything, and nobody's actually into my channel. So I think I've done a good job, and I'm now offering 5 gigahertz connectivity to my entire apartment with almost zero cross-channel talk. So hopefully that makes some sense visually for you to understand how all this works. Just to kind of point out, these channels here in the middle, don't really worry about those. Those have a lot to do with radar. If your router has the ability to use these channels, so how it works is whenever your router senses that radar is being used, and since we have an airport in Boulder, that's probably it's going to happen a lot. When it sees that, the channel that it's using for the radio, or the radar broadcast, then has to be shut off for civilian use. So what will happen is, once your device senses the radar stream, it will then switch your device over to an open channel that isn't part of these DFS channels that are in the middle here. So if it was me and I was setting up my wireless network at home, I would try and pick, you know, one of these other channels and see what's the cleanest for my area, if that makes sense for everybody. Okay, back. So we did the demonstration. Hopefully that makes some sense. We're going to move into the question part. I know we're a little bit over. I had some technical difficulties in the beginning, so I didn't know if Jamie has anything she wants to share, or anybody has any questions we could talk about.
Nothing really came up in the chat, but now's the time if anyone has any questions for Drew. Please, either you can speak or you can just put it in the chat. Also, if you have a question later on, you can send it to oitfeedback@colorado.edu. And yes, the slides are actually currently on the OIT website, which I will link right now. So
okay, we got one here. I can see it. I've heard of wireless boosters. What are they, and when they work when I have a DSL connection? So wireless boosters are a little different from the DSL modem that you have. So DSL is the type of connectivity that comes into your house. The wireless that you would then attach to the DSL connectivity to then offer connectivity to all of your devices inside is different. and they offer something called wireless boosters. So in that example that I showed of all of that big house, wouldn't it be nice to live in that big house? But in that big house, you may need to add extenders throughout to kind of boost the signal. So I lived in an apartment in Pittsburgh, and it was like a real long, like kind of hallway apartment. And I had my AP in my living room where the desk and everything was. And then we had a small little room by our front door, and I had to put a booster in there so that the signal could be extended. My wireless signal in my house could be extended to that little room. Hopefully that makes sense. Yes, your consumer cellular smartphone should be able to provide you with mobile broadband. You'd have to make sure that you have a tethering package onto that. And usually there are limits, like I said, to that. They only limit the amount of data that you can transfer, or then they'll throttle your connectivity down after you hit a certain peak. So it's not the best. It's more of like I'm a traveler, I'm a business person who travels a lot, and I need to jump and check my email real quick while I'm at the airport, and I want it on my own hotspot. That's sort of what's really used for. Like I said, we kind of want to push people away from that just because it's not a good tool to use for Zoom because of the upload speeds, like I showed earlier, right? A lot of these ISPs just don't offer the upload speeds. Now you can purchase better upload speeds, but it's just not worth the money to do that. And usually those are sold as business accounts. Anyone else? Sorry, I can't see anybody. So if you're all shaking your heads, no, I can't see because of my screens the way they're set up. So.
Don't worry about it, Drew. Most people don't have their videos on.
Okay.
So if there's any additional questions, you can just send it to oitfeedback@colorado.edu, and we'll be sure to get back to you. This meeting will be posted on the OIT website. And like I mentioned in the chat earlier, the slides for this presentation is currently there. So thank you all for attending. We appreciate your attention, and we hope you enjoyed this session.